Okay, so section 6.5, a general factoring strategy. So this just kind of puts everything together that what we've been talking about in the first part of chapter 6. So objective 1 is to be able to recognize the appropriate method for factoring. So you're thinking to yourself, how am I going to attack this problem? How am I going to factor it? So they say for the first one, you want to look for a greatest common factor, and you want to factor it out. So is there a number that you can divide into all of them to make it a little bit smaller? Then the next thing you need to do is determine the number of terms in the polynomial and try factoring as following. If there's 2 terms, can the binomial be factored by using one of the special forms? And remember, those 3 special forms are your difference of 2 squares, which is a squared minus b squared. And then you have the sum of 2 cubes, which is a cubed plus b cubed. And the difference of 2 cubes, which is a cubed minus b cubed. So you want to look for those special ways of doing it. If you have a binomial and it doesn't represent one of those, then you can't factor it any farther than what it is. Then if there's 3 terms, you want to look to see if it can be factored by using the special formula of a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. But again, like when I was telling you in the other video, I just go ahead and I factor those into my 2 brackets. So if it's not one of those, then if the trinomial is not a perfect square trinomial, try factoring by trial and error or grouping. So remember, that's where we can use the Kung Fu method, or we can just try to do the grouping method. Now, if there's 4 more terms, try factoring by grouping. Check to see if any factors with more than 1 term is in the factored polynomial can be factored further. If so, factoring complete. And you can always double check yourself by multiplying it back out through. Okay, so our first objective examples, they want us to name the appropriate factoring method. So when I look at this one, 24y squared minus 36y, the first thing I notice is that there's 2 terms. So 2 terms. And then the next thing I notice is that they have a 24 and a 36, and I know that if I think about what number goes into 24 and 36, they have a GCF of, 12. They can both be divided by 12, and they also have a GCF of y because they both have at least a y. So this one is just by factoring out the GCF. So if I factor out by using the GCF of 12y, what I do is 24 divided by 12 is 2, y squared divided by y is y, and then 36 divided by 12 is 3, and y divided by y is y. And so when I'm looking at that 2y minus 3, there's nothing more I can do. So to me, when it says name the appropriate factoring method, that would just be factoring out the GCF. 1b, name the appropriate factoring method. I notice that there isn't a GCF that I can factor out, but then I do notice that it's a binomial. And the next thing I notice is that there's a square. And that I also think about is the square root of 100 is 10. So to me, this would be factored by using the difference of 2 squares. So this would be a plus b and a minus b. So I would do this one as w plus 10 and w minus 10. So that would the name the appropriate factoring method would be the difference of 2 squares. Okay, so the next one, 1c, name the appropriate method. Again, I don't see a greatest common factor that I can divide out of it. And then the next thing I notice is it is a binomial. It's 2 terms. I notice a 3, and then I notice a plus sign. So this to me would be the sum of 2 cubes. And that would be the a plus b, and then the a squared minus ab plus b squared. And so a would be y, and b would be the cube root of 125 is 5. So my answer would be, change colors, y plus 5, and then y squared minus a times b, so that would be 5y, plus 5 squared, which is 25. So that's how I would factor that one. Okay, 1D. All right, so the first thing I noticed is that, again, there is not a GCF that I can factor out. But then the next thing I notice is that there's 4 terms. So 4 terms I would try to factor by grouping. So the appropriate factoring method would be grouping. So we could just kind of review that real quick. Let's see if we can do it. So what I'm going to do is I'm going to group it like this. The first group, I notice that I have a 3xy and a minus y. So it looks like the only thing that I can factor out is a y. So 3xy divided by y is 3x. Y divided by y is 1. There goes my dryer again. So then 6x minus 2, I can divide those both by 2. So I'm going to pull out a positive 2. 6x divided by 2 is 3x. 2 divided by 2 is negative 1. Notice that those two are the same. So then I can just go ahead and group my answers. So it's going to be y plus 2 and 3x minus 1. And that's how I would do that one. So the big idea there is just to analyze your problem and seeing what the attack method is going to be. So using general strategies for factoring, so we're just going to factor some more. So number or factor example 1, 24x to the third minus 3. So I'm looking at it, I'm analyzing it, and the first thing I notice, I can divide them both by 3. So I'm going to pull that GCF of 3 out. So I get 8x to the third minus 1. And then I look at it again and I go, wow, 8x to the third is a perfect cube and 1 is a perfect cube. So to me that looks like it's going to be the difference of 2 cubes. So I'm thinking to myself, a minus b, and then I'm going a squared plus ab plus b squared. Make sure I get my signs right. So a is going to be the cube root of 8x to the third, which is 2x, and b is going to be the cube root, I forgot my cube on that one, of 1, which is 1. So a is going to be 2x and b is going to be 1. I'm just going to put it in there. Bring my 3 down because he's still part of the answer. So I'm going to say 2x minus 1 for a minus b. Again, just like I explained in the last video, when you do a squared, and a squared is 2x, you got to say 2x times 2x, which is 4x squared, plus a times b, so 2x times 1 is 2x, plus b squared, which is 1. So then there's my factored polynomial. Okay, so the next one, whew, look at that guy. 32 and 2, well, I can factor 2 out. X the fourth, don't have any x's in the other one, so I can't pull anything out there. I have a y and a y to the fifth, so I can at least pull out a y from both of them. So I'm going to pull out a 2y out of the 32 x to the fourth y. So 32 divided by 2 is 16. X to the fourth, because I'm not pulling any x's out. Y divided by y is y, so no y's. Minus 2 divided by 2 is 1. Y to the fifth divided by y is y to the fourth. Once I do that, I analyze it again. It's a binomial. And then I notice that 16x to the fourth and y to the fourth is a perfect squares. So this is going to be the difference of 2 squares. So this is going to be the a minus b and a plus b method. Okay, so bring my 2y down, do my 2 brackets, 16x to the fourth, I'm going to break that up into 4x squared and 4x squared, plus minus, should make my parentheses a little bigger, y to the fourth, I'm going to break it apart as y squared and y squared. So there's my answer for my factored polynomial. All right, next page. Look at those numbers. 125, 50, and 5. So it looks like I can divide all those by 5. So I'm going to divide all those by 5. Now all the letters are different, so I can't, like this one doesn't have a Y. This one doesn't have an X, so it doesn't look like I pull any letters out. So I'm just going to try to pull the 5 out first. So 125 divided by 5 is what? 25. So 25 x squared. I'll erase my doodle there. Let's see. 50 divided by 5 is 10 xy. And 5 divided by 5 is 1. So then I just have y squared. All right, so then I look at it and go, okay, well, I got 3 terms. I got a trinomial in here. But look at this. I got the square root of 25 is 5. Square root of y is y, or 1y. And then I have 10. So I'm thinking to myself, I'm thinking that whole sum of 2 cubes where it goes a plus b squared equals a squared plus 2ab plus b squared. So I'm thinking to myself, 25x squared is 5x. The square root of y squared is y. And then if I multiply those two together and multiply by 2 to see if I get that middle term. And it does give me the middle term, so to me, that is the sum of 2 cubes. So I'm just going to, that's kind of an easy check. So I'm going to go 5, and then I know that it's going to be the 5x plus the y. And then I got to quantity square it because there's 2 of those. So just again, looking for those patterns to use. All right. So let's see what we're going to do. Let's see, I got a 5 and a 45, so I know I can pull a 5 out. Oops, I bet I can pull some letters out because I got an x to the fourth and an x squared. So I could also pull out an x squared. So let's see what happens when I pull out an x squared. So 5x to the fourth divided by 5x squared, x squared. 45 divided by 5 is 9. X squared divided by x squared is it. Okay, so now that's another pattern. That's the difference of 2 cubes. So 5x squared, a plus b and a minus b if you forget. So it's going to be x plus 3 and x minus 3 for our final answer. All right, next one. So you got a 4, a 16, and a 48. They're all divisible by 4, so I'm going to pull that 4 out first and then see what I get. So I got 4. Let's see, 4x squared divided by x squared is x squared. 16x divided by 4 is 4. And 48 divided by 4 is what? 12. Okay, so next thing I'm going to do is I'm just going to see if I can break that down into 2 binomials. So here's my 4. Bracket, bracket, x and x. And now remember, if this back one is a minus, my sign is going to be plus minus. I'm looking for 2 numbers that multiply to make 12 that have a difference of 4. So I'm thinking to myself, 6 and 2 make 12, and the difference between 6 and 2 is 4. Then I got to figure out which one is going to be negative. If I want a negative 4 difference, that means I'm going to have a negative 6. So then I got to put the negative, I got to put the 6 with the negative. So it's going to be 6 and 2 like that. And so then there's my final answer. These are kind of fun, aren't they? All right, so 4x to the fifth and 64x. Well, 4 times 4 times 4 is 64, so I think they're both divisible by 64. So I'm going to start there. Or sorry, they're both divisible by 4. And the first one has 5 x's, the back one has 1, so I can pull 1 out. So let's see, 4 divided by 4 is 1. X to the 5th divided by x is x to the 4th. 64 divided by 4 is 16. So then there's my answer. Now, looks like I could probably go farther because to me, this looks like a plus b and a minus b again. So, change my color here. So 4x, you always got to bring that down. Do my 2 brackets. X squared, let's see, it's going to be plus 4 and x squared minus 4. So do you think we're done? I think we got a problem. I think we got a problem with this guy because he is still the difference of 2 squares. So I got to take him even farther. This is kind of a long problem here. Bring my 4x down. Bring down that x squared plus 4, just like what we said in the last videos. You can't break the plus 4 down, so you got to leave it. So let's see. We can do this one as x plus 2 and x minus 2 because the square root of 4 is 2. Okay, so there's my answer on that one. Okay, so let's see. Next one. Doesn't look like there's a common number that I can pull out. So the next step is I got 4 terms. So that means I'm grouping that one. So I'm going to put some parentheses around the first 2 and the back 2. I got an x to the 3rd and an x squared. So I'm going to pull out an x squared. Let's see, I get x minus 4. In the back, it looks like I have a negative 9 and a 36. So I'm going to pull out a negative 9. Negative 9 divided by negative 9 is x. 36 divided by negative 9 is 4. Okay, so they match. So I'm going to have x squared minus 9, x minus 4. But again, after you analyze it, you notice that you can take this one farther. So it looks like on this one, my final answer, I can break that one down to x plus 3 and x minus 3, and then I have the x minus 4. The tricky part on these is to make sure that you get them factored all the way through. All right. So hopefully you're getting some good ideas how to approach these. All right, so got a couple more here. So let's see, 3, 30, and 75. Well, I think those are all divisible by 3. Then this one, the first one has 3 x's, the second one has 2 x's, and the last one has 1 x. So it looks like I'm pulling x out. So let's see, what did I say? I said 3x. So 3x to the 3rd divided by 3x is x squared. 30x squared divided by 3x is 10x. 75x divided by 3x is 25. Okay? So then I got a trinomial here. I'm going to try to factor it farther. So I do my 2 brackets, x and x. If the last one is a minus, then it's the first sign, so minus minus. What times what makes 25? That adds up to be 10, and that would be the 5 and the 5, and I go, oop, those are the same. So this is the sum of 2 cubes, so I wrote it like that. So I didn't recognize it was the sum of 2 cubes, but I was able to factor it out and then see that it is. All right, next one. All right, so I got a 2 and a 54. So those are both divisible by 2, and I got an x squared. So let's see, I can pull out a 2x squared. So 2x to the 5th divided by 2x squared would be x to the 3rd. 54 divided by 2 is what, 27. And then I look at that and I go, oh, wait a minute, x to the 3rd and 27 are perfect cubes. So I know that the cube root of x to the 3rd is x. That would be my a value. And then the cube root of 27 is 3, which would be my b value. I got a plus, so I got to use the sum of 2 cubes. So I'm kind of running out of room here, so I'm going to do a plus b, and then a squared minus ab plus b squared. Okay, so this is all that one. So, bring my 2x squared out. Let's see, a plus b, so I'm going to write x plus 3. And then a squared, so that's going to be x squared, minus a times b, so 3 times x, plus b squared, so 3 times 3 is 9. So there's my answer for that one. So again, just looking at those patterns. All right, next one, or next two. I think that's it. Okay, so we got 2 more examples. So 3 and 48. Oh, I know that they're both divisible by 3. And I got a y and I got a y to the 5th. And I said, well, I can pull out a y. So 3y. So when I pull a 3y out of 3x to the 4th y, I would have x to the 4th. And 48 divided by 3. I don't know why I can never remember that one. 16. So 16 y to the 4th. Okay, so that to me looks like it's the difference of 2 cubes, so I'm going to go ahead and factor that even farther. So my answer is going to bring down my 3y. Okay, so x to the 4th would be x squared and x squared, plus and minus 16y to the 4th. That's going to be 4y squared and 4y squared. Now again, ask yourself, can you go farther? And I see an x squared minus a 4y squared. So that one I can take a little bit farther. So I'm going to grab my pen here again. 3y x squared plus 4y squared. Then I'll break down that back one. So here's my 2 parentheses, x and x, plus and minus 4y squared. So to me that's going to be 2y and 2y. And that would be my final answer. Okay, whew, this one looks a little tricky, but it looks like they're all divisible by, what, 3? And they all have an x in them. So I could pull out an x. So I'm going to go 3x and see what happens. So let's see. 4x to the 3rd divided by 3x would be 4x squared. 36x squared y divided by 3x is going to be 12xy. 27 divided by 3 is 9. I pulled out the x, so then I have the y squared left. Okay, so let's see. 4, 12, 4 and 9 are kind of unique because they're perfect squares. So I'm thinking to myself, 4x squared is 2x. 9y squared is 3y. And if it's the sum of 2 cubes, if I multiply those 2 by 2 and get that number in that middle term, I will have a sum of 2 cubes, which I do. So that tells me that I'm going to use the pattern a plus b squared equals a squared plus 2ab plus b squared. So bring down my 3x, and then I'm going to have the 2x and the 3y. So 2x plus 3y quantity squared is my answer. Well, I hope that helps you with lesson 6-5. Again, if you have any questions or concerns, please don't hesitate to send me a text or ask me questions about the video. Anything you need. Thanks. Bye-bye.